I'm Dave Rochwerger. I'm the Director of Engineering for Agent Platform. I joined Trulia almost 4 years ago, which is part of Zillow Group. And like many of you out there, I've certainly written my fair share of bad code and hopefully some good clean code occasionally. I'm going to be talking to you today about clean code in large teams. Before I do, let me just tell you a little bit about us. At Zillow Group, culture is not just a buzzword, it's something that permeates everything we do. We go to work to solve hard problems with smart people. We believe that the best idea wins, and we strive very hard to have a healthy work-life balance. Slides going a bit fast. We have many teams across many offices. In San Francisco here, we have over 200 engineers alone. And we have many products, release cycles, technologies, and these all lead to many different code repositories, some of which up to 100 engineers are able to contribute code to. So I'm going to talk to you about 4 things today. What clean code is and why it's important, why clean code becomes harder in large teams, how important culture is when it comes to clean code, and how important it is for engineers to communicate their wins. So let me start off with clean code. There's a bunch of definitions out there, but the one I'm going to use today is that clean code is one that has low defects, is maintainable, and testable. So let's start off with the easiest one, low defects. Easy to understand, it's easy to talk to. It's also easy for you to explain to your business partners that clean code is one that has few bugs that come out of it and few design flaws. By maintainable code, I mean code that's intuitive and extensible, and not just by you and your engineers, but if I come along or some random person comes along and looks at your code, it should be easy to understand and obvious and easy on how to add to it. Testable. So I'm using the word testable here on purpose. Tests are obviously important for code. In fact, to quote Michael C. Feathers, who writes a really good book about refactoring legacy code, he says that code without tests is bad code. And that's very true, because if you don't have tests, when you change something, you don't know if it's for the better or for the worse. The reason I have testable here is that the very journey that you go on to write testable code intrinsically leads to cleaner code. And this is because to write code that is able to be tested, you have to use tactics like dependency injection. You have to have low coupling between modules and classes. Your classes have to have clear and simple responsibilities. So why do we really care about all this? Why is this important? Well, quite simply, every minute that you're fixing a bug, or every minute that you are diving down a rabbit hole through spaghetti code, or every minute you're maintaining a complex system, is another minute that you're not being productive. It's another minute that you're not building something awesome. And lastly, clean code's a pleasure to work with. If you have clean code, your team's going to have less pain on a daily basis, and you're going to have less pain when you want to onboard people. Large teams in big companies often looks like this, right? So you've got a bunch of different technologies, you've got similar but different solutions, all kind of magically working together in sequence like a Rube Goldberg machine, kind of like this one here. Whether by design or not, the larger your company gets, you're going to have more teams, more technologies, more frameworks, and even different processes and standards. At Trulia, we've had some light direction with architectural reviews or some engineering forums, but ultimately we've found that it's best to let every team choose a technology for themselves that will make them successful. It is a bit of a balance though, and you want to be careful about inefficiencies and disparities that you get. Secondly, communication. It becomes harder. I've seen difficulties within one engineering team communicating with each other. Jokes aside though, the more teams you have, the more offices, this is definitely more true. And what happens is that you end up having common code, or perhaps shared services, or versioned APIs, and all of these need communication and can possibly become a pain point. And lastly, culture. Culture is really important. The culture of your company is what sets the direction of your technology and how your teams interact with each other. What your company's culture is and how you as a team try to shape it can make a big difference. So I'm going to go back in time 1 year to 2014. In the San Francisco office, 2014 was a great year, actually. We launched some really cool and awesome products. And what we do at the end of every year is we get all the engineering leads from each team, and we go back and we look and reflect. What didn't we do well? What can we do better? Ended up with a pretty long list, as we do every year. I'm going to point out a couple of those. Number one, too many bugs. Now, you're always going to have bugs. That's just a fact of life. But we felt that some of our teams were weighed down by the amount of bugs that we had. It was affecting our velocity. We wouldn't be able to be as agile and as fast as we wanted to. Many engineers had issues with estimating and dealing with legacy code, so code that was written not to be clean, that wasn't maintainable. We had highly coupled, low communicative teams. All right, that's really just a fancy way of saying we had many teams that worked together that were dependent on each other, but the communication between them and about those shared resources wasn't good enough to overcome those difficulties. Many of the mistakes that we noticed in the year were preventable. So maybe you forgot to run unit tests, or you didn't write a unit test, etc. These were things that we could fix. And lastly, at Zillow Group, we have a lot of amazing engineers, but we also have a very high bar. And to that end, we felt that some of the knowledge around advanced OO techniques or testing or dealing with legacy code wasn't as consistently high enough as we'd like. So even throughout the year in 2014, it wasn't all that bad. And we certainly didn't wait till the end of the year to have our yearly discussion to make some changes. For example, in September last year, we took 100 engineers off work for 5 days, and we brought in external trainers, and they taught us stuff, advanced OO techniques, testing, and specifically dealing with legacy code. So companies like Trulia and Zillow, we've been around for a decade. So actually, just last month, Trulia had our 10th year anniversary, so go us. But the code that was written back then is still running today, or at least some of it. And unfortunately, what happens quite frequently in the early days of companies is that clean code's not really a thing. People don't think about tests, or they don't think about maintainability. And so even years later, when you want to add tests to code that's existing, it becomes very, very difficult. Secondly, we got the team leads together again, and we put together code quality guidelines. And we believe that if you followed these, we'd get some clean code coming out of that. It did prove quite useful for a document to use for code reviews. And now this wasn't all just a top-down approach. We had engineers all over the shop doing things and making things to make things better. They built tools, they built IDE plugins. We had Git hooks that would run test suites and code quality tasks before you could even commit code. And of course, like many companies, we had tons of Jenkins jobs that would run test suites and clean code tasks after code has been merged or at the time of building. So this is really good stuff. But we still felt that it wasn't enough. We wanted more. So for example, we talk about some of the tools that engineers had built, Git hooks or IDE plugins, etc. They were great, but the problem was the people who built them didn't socialize them, didn't get people on board. So we ended up having a hodgepodge situation where different engineers and different teams had different levels of clean code. Having Jenkins builds that run your test suites and code quality tasks when you make a build or at staging time sounds really good. And what often happens is a build's going to break, and your entire team has to stop what they're doing. And that sounds really motivating. The other side of the same coin, though, is that your team of 3 or 4 or 20 engineers is breaking out of their context, breaking their focus, and they're all paying attention to the broken build, when really you just want one engineer to go do something about that. So we wanted to look at this holistically. So for this year, 2014, we put together a couple of people to start a project to have a look into this stuff. We called this project Mr. Clean. The aim of this project was to encourage clean code and to discourage bad code. And we got together and we thought about what we wanted to solve, and we put together 3 goals. Number 1, push defect detection as early as possible. So this graph here, the y-axis is a relative effort. The x-axis is a stage in the code workflow. Now, when you're designing or writing code, whether it's TDD or otherwise, if you find a design flaw or a bug, really quick to fix it. Once it goes through the QA stage, whether that's a QA team or other engineers test it, it takes a little bit longer to find issues and fix it. Once you deploy your code, even in continuous deployment situations, to notice that there's an issue and to go find the cause and fix it takes longer and longer. So it was clear to us that we needed to push the detection of issues as far back in the cycle as we could. Number goal is so simple, doesn't need a graph. Make it hard to contribute bad code. Goal number 3, make it easy to contribute good code. Or as I like to think of it as, don't get in the way of people doing the right thing. We wanted to make it easy to automate away the things that we could automate away. So code style, let's not talk about it, just go fix it. If a unit test breaks, pretty clear that code shouldn't go in. But there's other things, functional tests, code smells. Those things need to be discussed, and that's what we wanted our code reviews to be able to focus on, the higher level things, the subjective things, and architectural design. Now I'm going to talk about the tool that we wrote on the next slide. But before I do that, projects like this are more about culture than they are about tooling. It's very easy as engineering leadership to lament the fact that there's bad code being contributed and come up with these tools and processes and say this is what's happening. But that's not the way things work. You're going to lose respect and you're going to be fighting an uphill battle. What you need to do is examine the culture. What is it that makes people or allows people or encourages people to do things that you don't think are right? You've got to listen. So I'm going to ask you 2 questions. Put your hand up if you guys have ever woken up in the morning and made a decision that you're going to write bad code that day. All right, I don't see any hands. Second question. Put your hand up if you have ever written or seen bad code in your workplace. All right, big difference, right? Nobody wakes up in the morning with the intention of writing crappy code. People want to do the right thing. Engineers want to do their best. So you really need to look at the culture and listen. Secondly, appealing to grassroots is important. You really need to get buy-in. So in our case of Mr. Clean, we wanted to get engineers excited about clean code. We wanted to get engineers excited about doing better and excited about encouraging each other to be better at their craft. Culture is so much more than after-work drinks. It's how your teams work together. It's how your teams communicate with each other and how your teams help each other. Clean all the things. So let me tell you a little bit about Mr. Clean. It's an app written in Python, and it integrates with Atlassian Stash. And for those of you who haven't heard of that, just think of GitHub internally, and also Jenkins. And what it does is it also changes the code workflow. So when a pull request is created, it can actually block that pull request. Now, most of you probably do know what a PR is, but just in case, a pull request is a piece of functionality that most modern version control systems have, or many of them do. And rather than an engineer merging code into a branch or the main line, they create a pull request with a set of changes, and then other engineers can review that line by line and approve it, and then it gets merged in. So what Mr. Clean does is, when you create a pull request, it kicks off a whole bunch of tasks in Jenkins, and if certain ones of those fail, it will block you from being able to merge that PR. Additionally, it provides subjective failures. So it's pretty clear to me, say, oh, there's a syntax error or your unit tests fail, you can't merge the code. That's pretty clear. But if functional tests fails, perhaps there's network connectivity issues, or there's bad data in your test database, those are things that need to be discussed. And that's also what Mr. Clean can do. Mr. Clean also runs across any language, so it's language agnostic. And we wanted to eat our own dog food, or to quote Dana, drink our own champagne or Bloody Marys. And it runs on itself. As soon as we could, we got it to run on itself. So I'm going to show a couple of screenshots. For anyone who knows Stash, this should look familiar. This is a zoomed-in screenshot of a pull request in Atlassian Stash. And on the top over there, you can see a merge button that's grayed out. And that's because, in this case, there's a code task that's failed. And in the green box there, it says one build failed. So the engineer can click on that, which will take you to a screen like this. And this is a different example, but this one has 2 code tasks that failed. And then they can further drill down and see, OK, what's going on? Why did this happen? So if I was to click on the code sniffer example, so one of those was code smells, it would take you over to Jenkins to a screen similar to this. And here in this example, there's 7 code smells that were violated. And just above the fold there, you can see the details of 2 of those code smells. Now, this particular one's not going to stop anyone from merging their PR, but this is when the reviewer or reviewers and the engineer look at this page and talk about it, and they make a decision from there. So again, Mr. Clean's not really about the tool itself. It's really about culture and so much more. And part of that is the approach. So firstly, we did heaps of testing. You guys probably do testing all the time. Testing's important. But something like this that can get in the way of people and their workflow, testing was critical. We also kept our goals in sight. My personal favorite was don't get in the way of people doing the right thing. I certainly did not want to feel the wrath of an engineer when I get between them and their code. We're an agile shop. We do a lot of things really, really fast. So we iterated. We built the smallest thing we could on 1 or 2 repositories with a couple of code tasks, and then repeated. And we got lots of feedback. We asked teams. We spoke to people. Coming back to testing again, really nothing like testing in production. So we did a bit of a stealth deployment. We picked a couple of the repositories where we have 100 engineers that can commit code to, and we turned it on. We turned off the blocking functionality because, I don't have a suicide wish. But we ironed out the final wrinkles that way. And lastly, communication. I can't say this enough. Communicate, communicate, communicate. So even though a lot of the engineers knew this was coming, they knew what Mr. Clean was about, they knew why this was important, we still sent out a ton of emails. We built up several wiki pages. We had a chat room that people could talk to and ask questions. I even stood up at the engineering all hands and explained what was happening and why it's important. It's things like this, preparing people, listening to people, and communicating your wins and communicating why this is important that makes projects like this work. So this is an active project, but let me go through a couple of results. Since May this year, 15,000 pull requests have been examined. Day 1 of launch, we found bugs. What does that mean? That means a pull request was stopped, the engineer goes, what the heck? And it turns out there's a bug. So that's really cool. The test suites for code repositories that use Mr. Clean are 100% usable to this day. Now, what I mean by that is, it's one thing to have tests for all your code, but for that test suite to remain usable, you need to run it constantly, and you need to respond to those failures. Even this year, I've seen new projects created with some really good code coverage, had test suites, and I kid you not, 3 months later, they just don't work. Now, either they weren't automated or they were automated, but people didn't care about the failures. And anecdotally, I had many people come up to me or members of the team and say, oh, Mr. Clean saved my bacon today. I forgot to run unit tests this one time, sure. Or this code snail pointed out something. These are really positive things. Everyone likes graphs, right? So bugs was important. I said that earlier. No one likes bugs. Some of our teams, bugs were down by as much as 30%. Now, I'm not going to admit that was the same across all the teams. Some teams was just 10%. This graph here, the y-axis is number of bugs discovered per week. The horizontal axis is the week number for one particular team. Prior to Mr. Clean, this team had an average of 10 bugs per week. After Mr. Clean was in use, they had 7 bugs per week. So this is some good, positive steps forward. What does the future hold? Well, we could do a lot of things. We've already started looking to using New Relic insights to get some visibility into this. We want to use Docker containers so we can run more advanced clean code tasks, such as integration tests. We'd love to get more languages on board. And honestly, I would really love to see this project open sourced. No date yet at this point, because it's proven so useful for us. Just briefly, this I actually put together about a month ago, actually. This is on test data. And this is an example of some of the New Relic insights reporting that we could do. The dashboards we end up with will have a lot more stuff, look prettier. The reason I have this here is not so much the graph here itself. It's more that, why am I doing this? Why are we doing this? It's because this is another avenue to communicate our wins and to give us visibility into why and how Mr. Clean is working. So at Zillow Group, we learned a lot of things over the last few years. I've got a couple of takeaways. One, clean code is important. And for the engineers in the room, it's not just good enough that you get on board and you understand and you like clean code, but you need to be able to speak to your business partners, to your product team or the CEO, whoever affects your roadmap, and they need to understand what clean code is as well. Clean code becomes harder in large teams. And this is because of things such as legacy code, if the code's been around for a while, or even just due to the other things we talked about, like communication gets harder, you have many different technologies working together. And the key to all of this is culture. Culture is king. Culture is the vehicle that you need to use if you want to go towards cleaner code. Listen to people and try to shape the culture in a way that makes people want to do better and help each other. And if you can take one thing away from my talk today, it's this. share your wins. Communicate what you build. Engineers, you guys and girls, people have such a passion for building things. You build tools, you change a process that's not working. And unfortunately, all too frequently, that's where it ends. So use that same passion to tell other people about the things you've built. Share with someone a new workflow that you did, or tell people about that tool. I guarantee you that if you have a problem that you're trying to solve, other people have had that same problem too. And if you do this, I guarantee that your entire company will be better off for it. OK, so that's all I have for the moment, but it looks like I have a couple of minutes for questions. So if there's any questions, let me know. And step up to the mic if so.
So you mentioned that clean code is important as one of the bullets there.
Yep.
And I was just wondering, how did you tackle the problem of bringing this concept to the business half of the company you work for? So it's easy to kind of, like you said, no developer wants to write bad code.
Yep.
But what about the other half of the business that might not understand fully this importance?
Well, that's why I said one of the other part of clean code is important, is being able to communicate that to your business partners, right? It's very easy, and if you can't do this across many teams, start with one team. Just go a couple of people, and you get a team that has bad bugs or feel like they have hard deadlines, and work with them, and then show that the product lead for that team, and they'll come around really quickly. It's proven that code with tests and code that's clean is going to have less bugs out of it.
Hi, just more question about Mr. Clean here.
Sure.
I'm trying to bridge what Mr. Clean does functionally outside of what people are already using pull requests with GitHub would be doing. Sounds like a cool product, but I feel like I'm not fully understanding what is the coordination between Jenkins and Stash there.
Sure, there's a bunch of different parts of it. There's some Java plugins into Stash, and then the actual main Python app actually coordinates the running of all these tools and coordinates reaching into the APIs of Stash and reaching into the APIs of Jenkins.
Okay, thank you.
Cool. All right, so if there's any other questions later, I'll be around near the stage. I know you guys are probably hungry, so I'll let you go.